Hello again, this is Mark Summers from Summers Technical Services. I'm going to continue on with our assignment 2, DIN-REL, picking up where we left off before. We've got our model created. It's a good model. We want to turn it into a great model. We're going to do that by adding parametric features, and we're going to do that by adding global variables. So I'm going to go Tools, Equations, and we're going to add a global variable for the thickness of the DIN-REL, because that can potentially change for different configurations. And we're going to add a global variable for the length of the DIN-REL, because that's changed as well. So I'll call the thickness of the DIN-REL little t. So I type in little t, hit enter, type in the value, which is 1, enter, enter. Now I'm back in the line. We'll do another global variable. The length, I can call it whatever I want, but I'm going to call it capital L. Capital L, hit enter, and for now the length of my DIN-REL that I'm buying from Phoenix Contact is 2,000 millimeters, and I'll leave it at that. So now I've got a global variable called little t, and I have another one called capital L, but it's not impacting my model yet. So I'm going to go inside my first sketch. Here's my front view, open up the tree, there's my first feature, there's the sketch. I'm going to right click on sketch and hit the top left button that says Edit Sketch. Once I do that, I get back to my sketch. And what I want to do is I want to change these 1 millimeter dimensions to not be 1, but to be little t. And the way to do that, I have to fast double click on the number, fast double click, and I don't type in little t, I type in equals. And when I do that, I get a little pop-up, and I'll use my down arrows, over arrow, and I'll select T. And so it puts in the quotation marks around it. So this is equal, open quotes, little t, close quotes. And when I say OK, I get this symbol here that looks different than before. Before it was number 1. Now it's got this sigma symbol out front, red. And so that tells me that's, right now it's 1 millimeter, but it's being driven by global variable T. So I'm going to do that same thing on the other ones. Fast double click on that 1, equals, use my arrow keys and go find little t, and then do the same thing over here. Fast double click, equals, global variables, t, and now that global variable is driving those dimensions. Now the model has not changed, but if I come in here and say Tools, Equations, and go change little t from 1 to 2, not surprising, that sketch dimensions update, and I get a 2 millimeter thick DIN-REL. Now you'll notice here, this is not correct anymore because this inside bin radius was 1 millimeter. This was 2 millimeter. I'd like to have this outside bin radius be driven by the inside bin radius and the thickness. And so let's go do that. So if I go back to my space bar, get my ISO view, I want to go inside my fillet command. That's the inside fillet. That's going to stay at 1 millimeter. I want to change the outside bend, outside fillet. So I'm going to select the fillet in the tree, right click, and top left button is Edit Feature. And right here where it says 2 millimeters, I'm going to change that to be equal to global variables t plus 1, because the outside bin radius is going to be whatever the thickness is plus 1, which is that inside bin radius. I don't anticipate the inside bin is going to change. If I did, I could make another global variable for the inside bin radius. Now that outside fillet is going to be updated when I update T, and now if I go back to my front view and hit rebuild, now this fillet on the outside is now going to be such that that shape is going to be consistent all the way through here. Now this thickness is 2 all the way through. And now if I go Tools, Equations, I go set little t back to 1 like it is on my data sheet. and it rebuilds itself. And not only does the thickness change automatically, but that outside fillet also changes because it's based on that T parameter. Now I need to change the length of my DIN rail. That's inside this feature right here. So I'm going to right click, edit feature on that boss feature. I'm going to change 2000. I'm going to type in equals, global variables, L, and then say OK. Now, same thing that happened with the sketch is happening with the length, and it's being driven by that global variable. There it is right there. It's got the sigma, the red sigma, that tells me that's not just 2000, that's actually equal to L, and L happens to be equal to 2000 right now. All right, so now what I want to do, let's go back to Tools Equations, and let's change it to 500 millimeters and see what happens. So if I change that to 500 millimeters, there it is. It updates the length correctly, but look at my pattern. My pattern is not correct because I asked for 80 slots and I no longer need 80 slots. I only need 20 slots for a 500 millimeter long DIN rail. I need this to update automatically. And I do that by controlling the number of slots with my global variable. And based on our calculations we did earlier, that equation is going to be equal to L divided by 25. Now that's driven by that global variable, and now when I check my pattern, it's going to stop at only 20 instances because it's computing that based on the length. Now if I go back to my original length, Tools Equations, I'm going to change one parameter, change this to say 1000. When I say OK, not only does the length update automatically, but also the number of slots updates automatically as well. There's the global variable, and there's now it's at 40 because it's L divided by 25. Okay, so we went from making a great model, we went from making a good model to a great model. So now the next step will be to go into the structural analysis module and do a stress analysis to calculate some deflections and stresses inside our beam due to some forces we're going to put on it. So that'll be the next module after this one.